So we've seen the use of an interface by using list of t to define the functionality we'd like different implementations to have, and then from that interface definition we go off and develop separate implementations. Sometimes we use interfaces in the other direction from the bottom up. We may have different classes that seemingly have no common behavior that we want to unify through a common interface. So we're going to look at that here. Suppose we have two different kinds of objects. One object is a bank account object, such as the one we've seen before. It offers deposit, withdraw, and get balance. And suppose we also have a stock holding object that has a number of shares, which never changes, and a price per share, which might change over time. The behaviors of our stock holding object would be to change the price per share in case the market fluctuates its price, and to get the current value of the stock based on the number of shares and the price per share. Now these two objects can live separately fine. They have nothing in common and we could use them that way. But suppose I want to find out your current liquid value, your liquid assets, let's say in dollars, based on your stocks and your bank accounts. So to do such a thing, I might create a list of, let's say, valuable objects. So valuable is the abstraction I'd like here. And it contains a list of all of your assets, say, represented as a linked list. What would it mean to be valuable? It would mean that we can find out the current value of the object, say in dollars, whether it's a bank account or whether it's a stock holding object. We're then going to insist that bank account and stock holding both implement this valuable interface. So we're beginning with the idea of two separate objects, a bank account and a stock holding object, and from them trying to create a common interface that lets us view them identically. Our goal would be to be able to create code such as you see here. We'd like to be able to have a list of valuable objects, let's call that list assets, and then add to that list a bank account object and a stock holding object. The type of the list, parametric type valuable, is able to represent either a bank account object or a stock holding object. Here we add a bank holding object that starts out with $100 and a stock holding object of 5 shares whose initial value is $10 per share. If we can get this to work, we can then write the code you see now, where the initial worth of your assets is 0, and we then iterate over your assets inside this list, each time calling getLiquidValue on a given asset and accumulating your worth inside this local variable called worth. At the end, we can print out how much your assets are worth by just printing out the value of the variable worth. Now it turns out Java offers us a cleaner way to think of this iteration. Instead of actually having to enumerate over the list, we can use the shorthand notation for each valuable asset in the collection assets. And Java automatically generates the iteration code that we saw before for this. This reduces the code to simply the loop and a single statement, worth plus equal asset.getLiquidValue. So in this loop, valuable asset declares a new variable of type valuable, which now can represent either a stock holding or a bank account object. We'll soon see how to get it to do that. And then assets is the name of the collection. And each element in turn is then considered as the worth is being accumulated. So that's what we'd like to get to, but how do we achieve this goal? So bank account offers a getBalance object, and stock holding offers a getCurrentValue. Bank account offers a getBalance method, and stock holding offers a getCurrentValue method. We would like to define a new method called getLiquidValue that offers perhaps the same information but through a common interface. And we're going to call the interface valuable. So the interface valuable is only going to have the single method getLiquidValue, and we're going to force each of the other objects, namely bank account and stock holding, to implement that interface. If we go back to the object design, here we see a bank account type, and it offers getBalance, deposit, and withdraw. And here's a stock holding type, which offers getCurrentValue and setPrice per share. And we're going to introduce the same method into each of them with the name getLiquidValue. Once that's in place, we can put the proper code in each object to return the right value. So for a bank account, getLiquidValue would delegate to getBalance, since the liquid value of a bank account is simply its balance. And inside stock holding, getLiquidValue would delegate to getCurrentValue, which computes the price per share times the number of shares you have. Viewed as their own object types, all methods defined on an object are available, including the ones we just added. So if I view bank account as a bank account object, the four methods you see here are available, and stockholding as a stockholding object offers its three methods. If I look at these same objects, but through a valuable interface view, all I see is the method that valuable offers, namely get liquid value. You could think of them as a pair of glasses that restricts your view. Even though you're looking at a stockholding object or a bank account object, all you can see through this particular pair of glasses is what the valuable interface offers, namely get liquid value. As another example of this, consider a bank account A reference and a valuable V reference, which both reference the same bank account object which has $100 in it. For the bank account reference A, we could say A.deposit, A.withdraw, and A.get liquid value. If we talk about it from V's point of view, all we can say is V.get liquid value. Even though it's referencing a bank account object, the only method available to the variable declarative type valuable are the methods defined by the valuable interface.